I tested this IC-LoRA through the LTX Director workflow on my RTX 5060 laptop, and I immediately ran into a few hardware limitations. With only 8GB of VRAM, 720p was the practical ceiling, and I had to keep each clip at around 5 seconds. Still, you can reliably run this LoRA on an 8GB VRAM system by sticking to 720p 5-second generations. You may not have much room to increase the resolution or duration, but the actual camera angle transformation is entirely possible on this level of hardware. This is CrossView Prompt, an experimental IC-LoRA. The easiest way to understand it is to imagine having a virtual second camera. You give it a reference video, tell it where the new camera should be positioned, and it attempts to re-render the same scene from that new viewpoint. The subject, action, and overall environment should remain recognizable. This is completely different from simply panning, cropping, or zooming the original footage. The model has to generate parts of the subject and environment that were never visible in the reference video. In other words, it performs a form of novel view synthesis. Using the LoRA is surprisingly straightforward. First, load the CrossView Prompt SafeTensors file as your IC-LoRA. Then provide the video you want to reshoot. Finally, enter a short camera angle prompt. You don't need a starting image because the video itself acts as the reference. The LoRA analyzes the subject, movement, composition, and environment before attempting to generate the requested alternative view. But there is one extremely important rule. This is not a free text camera LoRA. You can't describe the camera position using any wording you like. It was trained using a small, fixed vocabulary, so every prompt must begin with the trigger word CrossView, followed by 3 camera instructions in a specific order. The complete structure is CrossView, new camera angle, azimuth, elevation, distance. Azimuth controls the horizontal position of the camera around the subject. You can keep the same angle, move slightly to the left or right, move normally to the left or right, or move far to either side. Elevation controls the height of the camera. The available choices are lower, same height, and higher. Finally, distance controls how close the camera is to the subject. Here you can choose closer, same distance, or further. Left and right don't mean panning across the existing frame. They mean physically moving the virtual camera around the subject. Higher places the camera above the subject and looks downward, while lower places it below the subject and looks upward. When we combine 7 azimuth choices, 3 elevation choices, and 3 distance choices, we get 63 officially supported camera prompts. The creator has included every valid combination in this text file, so you don't even need to write them manually. You can simply copy the exact camera position you want. Make sure you use these phrases exactly as written. For example, don't replace "to the left" with 45 degrees to the left, because that phrase wasn't part of the LoRa's training vocabulary. It may still generate something, but the camera control becomes much less predictable. If you want to generate consistent AI influencers with full creative freedom and without running into refusal messages, check out my previous video. I covered a hybrid approach that can help you save a significant number of credits, and you'll also get a 15% discount if you sign up using the link below. Before trying the workflow, make sure everything is fully up to date. Here, you have links to all the models you need, and here's the link to the LoRA. I loaded the LTX 2.3 22B distilled model using the FP8 weight type. I also enabled chunked feed-forward processing, which helps reduce memory pressure on my 8GB laptop GPU. Inside the Director interface, I set the resolution to 720p, the frame rate to 24, and the duration to approximately 5 seconds. I then added my reference clip to the IC-LoRA video track. The CrossView camera command goes into the prompt field. This LoRA was trained using camera instructions alone, so I didn't add another lengthy description of the character or environment. Video attention determines how strongly the workflow pays attention to the reference video. I kept this at 0.65 for my tests, while the overall video strength remained at 1.0. This green Director Guide and IC-LoRA node is where the actual adapter is selected. I chose the CrossView Prompt file from the LoRA menu and set its strength to 1.5. This matters because the LoRA was trained on the full, non-distilled LTX 2.3 model. Its effect can be weaker when used with the distilled few-step model, and the creator recommends trying a strength between 1.2 and 1.5. Since I'm using the distilled model, I went straight to 1.5. I kept the scale at 1.0 and the image attention strength at 1.0. Finally, I used tiled encoding with a tile size of 256 and an overlap of 64 to make the workflow more manageable with limited VRAM. For sampling, I used 8 steps with the simple scheduler, Euler Ancestral Sampler, CFG 1.0, and full denoising. These are practical settings for the distilled model, rather than heavy quality settings designed for a high-end GPU. The biggest official limitation is the available viewpoint range. The training cameras only covered a frontal sector of approximately 60 degrees to either side. A direct view from behind is outside the model's trained range. So, far to the left, or far to the right, doesn't mean a complete 180-degree rotation. When we push beyond this range, the LoRa has to hallucinate increasingly large portions of the scene. That can produce some genuinely impressive results, but it can also change the subject, invent new background details, distort rigid geometry, or lose temporal consistency. The creator recommends chaining several smaller camera changes when you need a larger transformation. This means generating one modest angle change, using that result as the next reference video, and then applying another change. The trade-off is that errors can slowly accumulate with every pass. Also, this LoRa simply doesn't work with certain clips. I tested a wide variety of prompts with this clip, but the camera either changed only slightly or didn't change at all. The best approach is to use clean 5-second clips, keep the subject fully visible, avoid overly complicated movement, use the exact camera vocabulary, and begin with moderate viewpoint changes before attempting the more extreme prompts. Please leave a thumbs up, drop a comment, and subscribe to the channel if you found this tutorial useful. Thanks for watching, and I'll see you in the next video.